Hi everyone, my name is Naomi Gonzalez. I'm a high school student and I'm going to explain you the topic 9 of matter and energy, graphical, qualitative and quantitative description of forces. A force is a physical quantity vector. It can be represented by an arrow, and it describes the interaction between two objects, in contact or separated, which decide whether it is a contact or a non-contact force. Here we have some examples of contact forces: applied force, spring force, drag force, frictional force, and normal force. And examples of non-contact forces: magnetic force, electric force, and gravitational force.
The weight is a distance force due to the interaction between the mass and the gravitational field produced by
The
weight can be calculated with the formula that says that weight is equals to mass times acceleration. And here we can say that the acceleration is equal to 9.81 meters per second. The value of gravity. This value can be represented in newtons or pounds, and it is perpendicular to the contact surface. The tension of a rope is a contact force created due to the interaction of two equal forces in each point of a rope. A free body diagram is a diagram that shows the forces acting on an object. It can be represented as a Cartesian plane. The direction of the forces depends on the characteristics of the forces applied. The friction force opposes to the motion when there are two surfaces in contact. And there are two kinds of friction: the static friction when there is no motion, and the kinetic friction when there is motion. Since the friction and the normal are proportional, there has to be a constant. And this constant is called the static and kinetic friction coefficients. The static friction coefficient, it has to be always greater than the kinetic friction coefficient. Here we have some examples of approximate coefficients of friction. It depends on the type of material used. It can be wood on wood or steel on steel. Here we have a problem using the free body diagram. We can use the static friction coefficient as 0.6 and the kinetic friction coefficient as 0.4. And then we can say that we have the normal going upwards and the weight going downwards. The friction is always opposing to the movement of the P force. If we can find the P force, we need to say that the sum of forces in the x-axis is equal to 0. Then we clear for the P, and we have to use the static friction formula to know the value of P. We can say also that the sum of the y-axis is equal to the normal and the weight of the object. This time it has to be 100 newtons. Then we can say that P is equal to the coefficient of static friction times the weight, 100. P is equal to 125. And then we can replace the static friction coefficient with a kinetic friction coefficient, that is 0.4 times 100 newtons. P is equal to 40. To understand this topic better, we need to know that the static friction is the type of friction between the bodies which keeps the object at rest. The magnitude is more than the kinetic friction, and there can be a zero. And the kinetic friction is the force acting against friction when overcomes static friction and body comes in motion. Kinetic friction is the type of friction which slows down the moving object. The magnitude is less than the static friction, and there cannot be a zero. In case the problem gives us an angle, the force P will also have an angle. So the components in both axes will be represented in the free body diagram. Here we have the normal, the force P, the angle, the force of friction, and the weight. So here we can say that the sum of forces in X will be represented also with the cosine of the angle, in this case 40 degrees. And then we clear to get the force P. In this case will be 67.11 newtons.